All right, so since we have now gone through the whole process of sketching a function, we're going to finish out chapter 3 with this concept of sketching the derivative, and then we're going to throw in some particle motion problems here at the end of the chapter. So a couple of pieces of information when we're sketching a derivative. This is what we want to look for, and just kind of some tips for you. So what I always like to do is when I have the function, I like to start with the zeros. And I mean that in two different ways, either the x-intercepts, where it crosses the x-axis, being the zero of the function, or the derivative being zero, looking for the relative or local maxes and mins. Okay, so those are the two starting points that I look for, depending on which way I'm going. If I'm going from f to f prime, I'm looking for the derivative being zero. If I'm going backwards, like f prime to f, I'm looking for the x-intercepts, and you'll see what I mean here when we go through this. One of the biggest mix-ups that students have in this section is confusing slopes with values. So if I say like a positive slope or a positive value, just understanding the difference between those. You could have a positive slope that has a negative value, and vice versa, a negative slope with a positive value. But that is something that I'll try to emphasize when we're doing these graphs, and it's just something that you really need to just think about the difference in those two. And again, when you're going from derivative to function or function to derivative, it's you're going backwards, so it just depends on which way you're looking at that. And then the other concept that I see being confusing is just the concept of something being less and more positive. A slope having, or a graph having a slope of like 10, or a slope of like 1/2. Those are both positive, but clearly 1/2 is a smaller positive. So, and it just the opposite for negative. If you have a function that's the slopes are becoming more negative or less negative. Those two things are probably the problems that I see the most often, is just getting those two mixed up and confused. Students just being confused with slopes and values, or this concept of less and more positive. Now, when we're looking at something being less and more positive, that's where we kind of look at the point of inflection. The derivatives being zero is our critical value. So, it's important for us to recognize rough estimates of where the critical values and the points of inflection are on the graph, and what happens to those values as we go from a function to the first derivative, second derivative, third derivative, so on, or backwards if we're starting with the second derivative and we go to the first derivative and then to the original function. What happens to the points of inflections as we go from one direction to the other? What happens to the critical values as we go from one direction to the other? So just keep those in mind. I don't really have any notes other than those pointers. We're just going to jump right into some examples here. I'm going to basically just look at our, let me slide these down so they're in the middle. So let's say here this red function is this is just my function f, okay? So this is f. I want to graph f prime. So I want to graph the derivative of this. So like I said, what I start with is if I'm going from f to f prime, I'm starting with my zeros on the derivative. So wherever the derivative is 0, this value here, let's just call that a, it occurred somewhere somewhere in this area. So this value of a, because the derivative was 0, that translates to a derivative on f is a value on f prime. So, all of the slopes in this function translate to values. So one thing we can think of, if we write this a different way, we tend to think of our axes in terms of like x's and y's, right? So if I look at this right here, these are my x values. Now x values are pretty consistent. They're not going to change, but my y values here are the vertical axis is the y-axis. Over here in this function, this is still my x-axis, but now instead of this being the y, this is y prime. So that's one way to kind of think of that is Any slopes over here become values in the derivative. So the slope right here was 0, so in my derivative that is a 0. So now this is where the concept of less and more positive come into play and less and more negative. Now all of the slopes over here are going to transfer over to values on this graph. So if I look here, like let's just pick a number. Like let's say the slope right here was -5, right? As I'm getting closer and closer to the vertex or this relative min, you could see that somewhere in here, let's just say right here, the slope of this would be like a -1. So you can see that this is becoming less negative up to the point where like somewhere in this area, let's say the slope was like -1/2. So now if these are relating to values in this function, this value at this part of the graph right here, since it had a slope of -5, the value over here would be somewhere in that area of -5. We don't know exactly what it was, I'm just making that up. And then as I got closer and closer to this point A, which is this point, they're becoming less negative. Like there was some point right here that was -1/2. There was some point right here that was like -1. But overall, this would have a straight line like that. So, the further up we go up this graph, the more negative these become. Like way up, you would have like a -100, and it would just continue. And yeah, so these are becoming less negative until we hit 0, right? And then it does the opposite over here. Like there would be a value over here that would be 1/2, right? So there'd be a value like here that would be 1/2. There'd be a value over here somewhere that would have a slope of 2. There'd be a value over here that would have a slope of, +5 or whatever it is. So these are becoming more positive. So, and they continue to become more positive. So after it goes through this point here at the x-axis, it's going to continue upward. Now this is where having a general idea of these derivatives will really help you, because if this is an x squared function, right, we know it's an x squared. When I take the derivative, it's going to give me a linear function, just x, right? So that kind of helps us to graph these because we can have a general idea of what the derivative should look like. If I'm starting with a parabola, the derivative should look like a linear function, right? So that's one way to think of that. Now, let's go backwards with the same graph. So I'm going to call this f prime and x, and this is going to be f, just the function f, and this is x. Okay, now what I'm going to do is just work in reverse now, okay? So on this one, I looked for the derivatives being 0, and I transferred them over here. On this one, I'm looking where the function is 0, so here, let's call this value a, and let's call this value b, and those will translate to maxes and mins. Now, if you remember back to when we did maxes and mins, if something was a max, right, if it was a max, the derivative went from a positive to a negative, right? That's supposed to be an arrow, right? A max had a positive slope and a negative slope. So on the derivative graph, that should translate to positive values and negative values. So you can see these are all positive values, and then they go into negative values. So A was a max. And mins, remember mins from our tables and whatever, went from a negative to a positive, right? Like a negative to a positive on your slopes. On your values, they go from negative values, like these are all negative values, to positive values. So B then would be a min. Now the reason why I say that is because if A is a max and B is a min, I'm going to put A, so let's say here's my A value, I'm going to put that point of A higher, then I'm going to put my point for B. Okay? Now those are relative max and mins, they're not absolute max and min, so we don't know that they would be the overall max or min of the entire function, and in most cases they are not. Okay? So let's continue this out here now. So all of the values to the left of A, if I'm looking at all of these values as I follow the graph this way, These are positive values, okay? They're negative slopes, but they're positive values. Positive values in f prime came from positive slopes in f, right? So if these are all positive values over here, not positive slopes, I'm not looking at the slope of it, they are negative slopes, but if those are all positive values, that means that all of the values to the left of A had to be positive slopes. So if I'm drawing that, my only option is to go up or down, right? I can go up or down, or I could stay flat if it were zero, but these aren't zero, they're positive or negative. So this right here, if we look at this, these are all positive slopes. Like if I pick any point on here, these would all have a positive slope. That translates to positive values on f prime. Now all of these values between A and B are negative, so they will all have negative slopes. Right here is the most negative it would be. So what does that translate? Think about this. What does that translate to on the graph of f? Think about that for a second. If I have the graph of f and that created this point right here, think about what would that be if I were to graph f double prime, what would that be? And that would be a 0, right? This is a 0 on f double prime. So our second derivatives being 0 means we had a what? And hopefully you're thinking point of inflection. So this value right here is where our graph would change from being, so let's just say it's right here, would change from being concave down, concave down to concave up. Let me redo that because that looks terrible. That's where our graph would change from being concave down to concave up, or vice versa, concave up to concave down. So after this value, all of these values are let me back up. All of these from that point to B are still negative values here, so they're negative slopes here. So all of these slopes are still going to continue down to B, and then after B, these are all positive values, so that means they would be positive slopes. So I'm coming down and then going back up. Okay, and I would make it a little more curved than that. Mine kind of looks a little bumpy, pointy. We don't want it to look too pointy. So, if you need to, come back and erase and, make it look a little more curved or rounded, go ahead and do that. So that would be that process there. Now, this graph could be anywhere. I could have drew it right there. I could have drawn this graph like up here somewhere. It would still have this same general look to it, but it could be anywhere on this graph, right? Like I could have drawn this blue graph up higher or down lower, but it would have been right there. And I'm mentioning that for a specific reason that you'll see, you'll understand later on. But so that blue graph could be higher than that or lower than that. Okay, when you're going from a function to, or a function's derivative to the function, that could be moved up or down. But if you're going from a function to the derivative like we did back here, those are a little more specific in the way that they need to look. All right, so let's do this again. I think I have 2 on here, yeah. So this is f. I'm going to go to f prime, okay? So if I'm going from f to f prime, what I am going to start with on this purple graph is I'm going to start with my derivatives being 0. So right there, so let's just drop this down. Let's call this A. And right here, so we'll call that B. All right, so if this is A and B was pretty close to the y-axis, there's my B, those would have zeros at those points, right? Because the derivative here is 0 and the derivative here is 0. All right, now let's look at what happens outside of this. So what's going to happen to this graph? Let's start with to the left of A. So if I'm going from f to f prime, I'm thinking of the slopes. So what do the slopes look like here from the left side of A approaching A? They're really, really, really negative, and then they become more and more, less negative. I'm positive, sorry. They're negative values, but they're positive slopes. Like this slope over here would be like 10 or something like that. And then we'd have a slope in here that would be 5. And then getting really close up in here, we would have a slope of like 1/10 or something like that. So they're becoming less positive, okay? But they are still positive. So what we're going to do is these are big positive numbers, and we're going down to A. So this would look something like this. Big positives going down to 0. They're becoming less positive down to 0. Now what happens between A and B? These are all negative slopes. So we have a negative here of like, like this right here would be a negative 1/2. And then this down here would also like be a negative 1/2, right? Like somewhere in between there, we're going to have this point where it switches over, where it becomes the most negative. Whatever that negative value is, that's the most negative it'll ever be. And again, what is that point? That's your point of inflection. So point of inflections over here become your most negative or positive values. So this is, like I said, it's going from like negative 1/2, negative 1/2 down to negative 5 or something, and then back up. Make this a little more straighter that it's not. I'm going to make it worse by trying to fix it. Let me back up a couple steps here. Oops, too far. So we want to be able to just show exactly what's happening here. Sometimes you're going to have to do this. You're going to have to erase something just to make it look a little better, right? So, I'm going to follow this down, go through that point to my point of inflection, and then back up. So let's just pretend it hit that point. And then what happens after B? Well, these are small negative or small positive numbers, like 1, and then going up to more positives, like 5, and then way up here we would have a positive slope of like 30. But they're continuing to be positive slopes. So that means over here these are all positive values, so it would go up. Okay, and again, it's a good idea for you to understand that this is an x cubed function. So if I'm taking the derivative, I should end up with an x squared function. Okay, so again, it's a good idea to just keep that in mind of what's happening there. Okay, on the last one here, what I want you to do is pause the video. I want you to label which one was F, which one was F prime. Oops, that's 2 primes, back up. Which one is F prime, and which one is F double prime. Okay, so pause the video and try to work that out and see what you can come up with. One of these is F, one is F prime, and one is F double prime. Okay, so I'm going to start with the purple graph here in the middle. Okay, now if we were to start with this graph, we want to be able to see what are some zeros here. Okay, so 0 derivatives. So let's say if I have this is a 0, we'd follow that up. I tried to make these on the same scale so it would be a little easier. I have a 0 there, and then right here I have a 0 that was supposed to go straight and I missed it. It's kind of following the graph there. So let's make this one go straight. I did it again. Straight up. There we go. So I should have 3 zeros. So if I'm starting with this one, I can see that this has 3 zeros in the same general area as these, right? There's 2 on the left side of the y-axis pretty close together, and then 1 on the right side. So then let's look at what's happening here. So all of these values, let's call this A, this B, and this C. All of the values to the left of A, those all have negative slopes. They're all going down. They're negative slopes. Okay? So if those are negative slopes, let's just say if this is F, then in F prime, they would have to translate to negative values. So these are all negative values leading up to A. And then between A and B, we can see that we have all positive values becoming most positive right in this area, and then going back down to 0. But these are all positive. It just starts at 0, becomes more positive, and then less positive. So starting here, it's more positive, less positive. Okay, so this is A and this is B. So we can see that so far we're still following that trend. Everything between B and C, these are all negative values. And again, somewhere in the middle there, we would have the most negative that this would be, which you can see is this point right here. That's the most negative. Okay, and then it continues back up. Even though these are all negative values, these are less negative values going back to 0. So there's your C value. And then what happens after C? They're all positive slopes, so that translates to positive values. Okay, so there's going F to F prime. And now we want to see, does the F prime go, is this still F double prime, or do we have something mixed up? So let me clear off these points here, and let's work with that one now. So let's say if we have some values here. Let's look at our slopes. I want to see where are the slopes here 0. So I have a 0 right here, and I have a 0 right here. So just to the right of the y-axis, and just to a little bit further to the left of the the y-axis. So you can see just to the right of the y-axis. So that would relate to, let's use different letters. Let's say this is E. Let's try and do this. That's E. And let's call this D. So E is very close to the y-axis, where D is a little bit further away. So let's label these D and E. So we would have that. What happens to the left of D? So all of these slopes are positive, right? More positive becoming less positive. So more positive values becoming less positive values. Between D and E, these are all negative slopes with our point of inflection, right? This is a point of inflection, which is where it's the most positive or most negative, being there just a little bit to the left of the axis, and we can see that that is what's happening here. So it becomes it's negative, becoming more and more and more and more negative, and then it becomes less negative, less negative, less negative, back up to E. And then what happens after E? Well, all of these values all of these slopes are positive, so we have positive slopes. Continuing after E, these are all positive values. So this is the correct labeling of F, F prime, and F double prime up top here. Okay? We're going to spend quite some time on this because I know this is probably one of the most confusing topics. It's just really abstract to try and wrap your brain around this. So I'm going to give you a practice worksheet today. I'm going to give you another practice worksheet on Wednesday. And then next week when we follow up with this, it's going to be the same thing. We're going to be working on this for a few days. So yeah, if you have any questions on this, let me know. Otherwise, I'll send you the worksheet. Practice the worksheet, try it out, see what you think, see how you do with it, and let me know if you have any questions.